This is a good question related to mixtures. And while it is not a very complicated question, we will see how using the traditional method would have been time consuming and the calculation would not have been convenient. Then we'll look at the better method. So here we have two containers of the same volume. The first container half filled with sugar syrup and the second container half filled with milk. Half the content of the first container is transferred to the second container, and then half of this mixture is transferred back to the first container. Next, half the content of the first container is transferred back to the second container. Then the ratio of sugar syrup and milk in the second container is what? So here, if you use the traditional method, see, first of all, everyone can see that we don't have any actual values in the question. So we can happily assume a convenient value. But the problem is that most people, they would think that 100 is a convenient value because that is what they are used to assuming. So if you see the problem with that, here we have the first container and then we have the second container. Let's take their totals to be 100, which is what most people would assume. Now, first container, we have sugar syrup and milk. Second container also, we will have sugar syrup and milk. Now, first container is half filled with sugar syrup. So out of that total 100, we have half of it, 50 is sugar syrup and 0 is milk. And of course, second container also total is 100 because the containers have the same volume. And out of this total 100, it is half filled with milk. So 50 will be milk and 0 will be sugar syrup. Now, half the content of the first container will be transferred to the second container. So out of this 50 sugar syrup, half of it, 25 will be transferred and other half, 25 will be remaining. So the 25 that is being transferred will be here in the second one. So this will become 0 plus 25, which is 25. Milk, we had 0 in the first container, so nothing will be transferred. Okay, so milk will remain the same. Now what is happening is, half of this mixture is transferred back to the first container from the second container. Now the thing is that here we have 25 and 50. So total is 75. Half of 75 that is being transferred, that will be 37.5, which will be a decimal value, not convenient for calculation. Okay, so if I show you the technical approach, it would be that here we have sugar syrup and milk, 25:50. So that is in the ratio 1:2. So if you look at how much sugar syrup would be transferred back to the first container. First of all, sugar syrup would be 1 part out of the total 3 parts. And the total quantity that is being transferred back, that would be half of 50 plus 25, because it's been given. Half of it is being transferred back, half of the mixture. So out of 75, half of it would be 37.5. Now you can calculate this. It's not too difficult also. It would be 12.5. But then of course, we'll be dealing with decimal values, and this is not even the last step. After we transfer back to the first container, after that, we again have to transfer back to the second container, more decimal values. So it would take a lot of time to do these calculations, and there would be a good chance of making a mistake as well. So what advantage would you get with this method? None at all. You would be at a disadvantage. So now let's see the better method that we can use instead. So first container and second container. First thing we have to understand is that we don't even have to look at the same, we don't even have to look at the total volumes, the total capacities. We just have to focus on how much sugar syrup and milk are actually there. So the containers have the same volume, which means half filled will be the same quantity. So we can just start from here. Okay, whatever is the quantity of sugar syrup in the first container, that will be the same quantity of milk in the second container at the beginning. Now, what should we assume for these quantities? We saw that 50-50 was not convenient. Why? Because we were having to divide by 2, because we had to continuously take half of the content, half of the content. Half means 2 in the denominator. And then after a point, we were getting values which were not divisible by 2. That was giving us decimal values. So now that we understand the problem, we can think, okay, if we have to keep dividing by 2 because of this half, then let us take value which is divisible by 2. And divisible by 2 how many times? This process is happening 3 times. We'll take half of the content here, half of the mixture here, and then again half of the content here. Half, 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 so we are doing it 3 times. So if you take half to the power of 3, that will be 1 by 8. So overall, we need to make sure that whatever value we are assuming, that is divisible by 8. Because ultimately we are getting 8 in the denominator. So this is a very simple understanding you need to have to assume convenient values. And then you will not have to deal with any decimal value. Let's start. So now sugar syrup, milk in both the containers. Now first container is half filled with sugar syrup. So let's say that sugar syrup is 8 here. Total of course will become 16, but that doesn't matter. Okay, so sugar syrup 8 and milk 0. And second container half filled with milk. So milk will be 8 and sugar syrup 0. Now, half of the content of the first container is transferred to the second container. And of course, the convenient part is that 8, half of it will be an integer value. So half of it, 4 will be transferred, 4 will be remaining. Okay, and the 4 that is being transferred, so we'll get 0 plus 4, which will be 4. No change in milk because milk was 0 here. So milk will remain 8 here. Then from the second container, half will be transferred to the first. So half of 4, 2 will be transferred and 2 will be remaining. Okay, so first container will increase by 2, 4 plus 2, 6. Similarly, milk, out of 8, half 4 will be transferred, 4 will be remaining. And the 4 that is transferred, so first container, milk will increase by 4, it will become 4. And now the same process from first container, half is transferred. So 6, half is transferred, 3 will be remaining. And 4, half is transferred, 2 will be remaining. And now here, out of 6, half is transferred, so it will increase by 3, 2 plus 3, 5. And then here, out of 4, 2 is being transferred, so it will increase by 2, it will become 4 plus 2, which is 6. And now the question is asking ratio of sugar syrup and milk in the second container. We can easily see 5:6. So our answer will be option 1. Now, of course, this last step here, we did not even have to look at. So if you are very focused on the question, ratio of sugar syrup and milk in the second container, you don't even have to look at this. You can just think, okay, out of 6, half 3 will go here. So we'll get 2 plus 3, which is 5. And similarly, out of 4, half 2 will go here. So we'll get 4 plus 2, which is equal to 6. So you can see this process would make sure that you are dealing with convenient numbers. And that will make your calculation faster, easier, and reduce the risk of making calculation mistakes. Okay, so make sure that you're understanding the logic behind this, why we are taking 8, because we have half, which is 2 in the denominator, and that is happening a total of 3 times. Okay, so if you've understood this logic, now you can practice a similar question. Make sure that you apply the same better method, the same logic, and put your answer in the comment section.